Hi students, in this week's video, I'll be providing you with a follow-up from the previous one that I've done on trigonometry curve sketching. This video, I'll be giving you a summary of what are some of the things you have to look out for when you need to sketch or solve problems involving sine, cosine, tangent curves. And also at the end, I'll be providing some O-level questions, some tips on how we can go about solving some O-level questions. So please stay till the end. Let's start off by motivating ourselves with an encouragement quote from Mr. Benjamin Franklin. And it's written as such: an investment in knowledge pays the best interest. Right, so we've come to the second part of the trigonometry curve sketching. In this video, we'll be doing the cosine and the tangent curve. So let's start with cosine curve. Right, so I've used the online graphing calculator, the Desmos, to create these three different curves. The red one is y equals to cos x. The blue one is y equals to 2 cos x, and the green one is y equals to 3 cos x. Right, so let's look at the maximum and the minimum values of y and the corresponding values of x. Alright, so for the curve y equals to cos x, you can see quite clearly from the diagram that the maximum value of y happens at 1, and the two corresponding values. You can concentrate on this point here and this point here. Right, so for the maximum value y equals to 1, the corresponding values of x are 0 degrees and 360 degrees. Let's go on to find the minimum value. It happens at this point here, where the minimum values of y is -1 and the corresponding values of x is 180 degrees. So in this case here, it's slightly different from the sine curve, and the shape of the cosine curve, it's also different from the sine curve. Right, so for the cosine curve, it's like a valley. Or a buttercup, okay, or a hat, inverted hat. Right, so that maybe these are some ways that you can remember the shape of the cosine curve. So let's look at the second curve, which is y equals to 2 cos x. Right, and we can see that the maximum value of y is 2, right, which is the same as, when I say the same, means if you were to recall, when we do sine functions, the coefficients of your sine x will gives you the maximum and the minimum value, right? So for y equals to 2 cos x, the maximum value of y is 2, and the angle is still at 0 degrees and 360. The minimum value is -2, and the corresponding value of x remain at 180 degrees. Let's look at the last one. Okay, so what is the conclusions we can make here? Right, so the conclusions we can make here is, if you're given a generic functions y equals to a cos x, then the maximum value of y is equals to the positive value of a at x equals to 0 degrees or 360 degrees. However, if you're talking about the minimum value, then it will happen at y equals to the negative value of a, and it happens when x is equals to 180 degrees. Okay, so this is the basic information that you have to remember for cosine curve. Right, so like what we have done for the sine curve, let's do also the same for the cosine curve. Let's examine what happened when you're given y equals to cos 2x, y equals to 2 cos 2x, and y equals to 3 cos 2x. What's the difference? Yeah, so for y equals to cos 2x, the maximum value of y still happens at 1. However, you see that the angle that gives you the maximum value of y1 would happen at 0 degrees. And in this case, it's no longer 360, but rather is 180, which we get it by taking 360 divided by 2. Then the minimum value, so this is taking 360 divided by 2, which is the same concept as what we have learned for the sine curve. The minimum value of y is -1, and that happens when your x is 90 degrees, which we get it by taking 180 degrees divided by 2. Right, so let's go on to the next one. Okay, so it changes only in terms of your maximum minimum value of y, but the corresponding values of x will remain the same for y equals to cos 2x, y equals to 2 cos 2x, and y equals to 3 cos 2x. Okay, right, so therefore, if you're given a generic one, which is y equals to a cos bx, I would say general, not generic, use the wrong word. If we're given general form, y equals to a cos bx, then the maximum value of y, max cy, will be the positive values of a at x equals to 0 degrees. The second one will be 360 divided by b. And your minimum value of y will be the negative value of a, and this happened at x equals to 180 divided by b. Right, so as with the sine curve, the cosine curve can also be expressed in the form y equals to a cos bx plus c, or y equals to negative a cos bx plus c. Right, so where a represents the amplitude of your curve, and the period for the cosine curve will be the same as the sine curve, which is 360 degrees divided by b, or 2 pi divided by b. And the axis is the same also as in the sine curve, y equals to c. The only difference is in terms of the shape of the curve, and also the maximum minimum values of the curve and the corresponding values of x. Right, let's look at 2 examples on how we can apply the concepts we've just learned. So in example 1, we're asked to find the maximum and minimum values of y and the corresponding values of x for the function y equals to -2 cos x minus 1. So to find the maximum value, we're going to substitute cos x to be -1, because you're given -2 here. So with this -2 as the coefficient, I need to multiply with a negative number to get a bigger number. Right, so therefore I need to substitute cos x to be -1. And if cos x is -1, then the corresponding values of x will be 180 degrees. So hence the maximum value of y equals to -2 cos x minus 1 will be -2 times -1 minus 1 gives you 1 at x equals to 180 degrees. And the minimum value, we're going to substitute cos x to be 1. And if cos x is equals to 1, then the corresponding values of x will be 0 degrees or 360 degrees. Alright, that's another way to verify it, and let's just use a calculator. You can just use a calculator, key in cosine 180, that will get -1. Use a calculator, key in cosine 0, you get 1. Cosine 360 degrees, you get 1. Alright, so the minimum values of y equals to -2 cos x minus 1 will be -3, And that happens when your angle is 0 degrees and 360 degrees. Okay, so I've given you another example. What happened if you're given 2 cos 2x? Instead of cos x, it's cos 2x and then plus 3. So in this case here, we're going to substitute our cos 2x to be 1 for the maximum value. And our corresponding angles will be 0 degrees divided by 2, that still gives you 0. However, for the second angle will be 360 divided by 2. Okay, that gives you 180. And then for the minimum value, we substitute cos 2x to be -1. And that happens when the angle is 180 divided by 2. Gives you 90 degrees. Right, so if you're given y equals to something cos 3x plus something, then the corresponding values of x, for the maximum value of y will be just 0 degrees divided by 3, 360 divided by 3. For the minimum value will be 180 divided by 3. So this is how you find the maximum minimum value and the corresponding values of x for the cosine curve. Alright, let's do also a summary for the cosine curve. To find the amplitude for the cosine curve, right, so if you're given the function itself, that means you've given y equals to a cos bx plus c. So it could be, if you're given y equals to 2 cos 2x minus 1, or y equals to -2 cos 2x minus 1, then the amplitude of the curve would just be the positive values of a, which if you are using the examples I've just gave you, then your a is equals to 2. Sorry, the amplitude is equals to 2. The a can be positive or negative. Okay, so in this case here, then the amplitude is equals to 2. Right? So if you have a equals to 2, then it is an upright cosine curve. If it's a equals to -2, then if a is equals to 2, it's an upright curve like this. If a is equals to -2, then it's your head. Okay, it's an inverted kind. Alright, another way of finding the amplitude would be similar to what we've learned in the sine function. That's taking the maximum value minus away the minimum value, divide by 2. Alright, let's also provide a summary for finding the period of the cosine curve. So if you're given the cosine functions, right, then to find the periods of the function will be 360 degrees divided by b, or 2 pi divided by b. Right, so let's have an example. Supposing you're given y equals to 2 cosine 3x plus 4, or y equals to -2 cosine 3x plus 4, then in this case here, the period would just be taking 360 degrees divided by 3, this value here, or 2 pi divided by 3. And if you're given the diagram, similar to what we have learned for the sine functions, you just have to recognize one cycle, which is highlighted for you in green. So in this case here, the range is between 0 to 90, and hence the period will be 90 degrees, or pi over 2 if the unit given is in radian. So how about finding the axis of the curve, y equals to c? Yes, the formula is still the same as what we've learned in the sine function. You just take the maximum value of y plus the minimum value of y divided by 2. Right, so now let's look at the tangent curve. to be honest, the tangent curve is a much easier curve to sketch than the cosine and the sine curve. Right? Basically, why? Basically because the tangent curve has no maximum minimum values. Okay, but it has this thing called the asymptotes. Right, so you need to recognize where the asymptotes are. Okay, and the periods for the tangent curve is different from sine and cosine. The period for one cycle for the tangent curve is 180 degrees or pi. Okay, and how do you think the tangent curve will look like? Yes, but before we talk about how the tangent curve will look like, we need to know where are the asymptotes. So for y equals to tangent x, y equals to tangent x, the asymptotes happen at x equals to 90 degrees, 370 degrees, or negative 90, negative 270. Alright, basically you can use a calculator and then you can just key in tangent 90, the calculator will tell you error. Or tangent 270, it will be another error. Tangent negative 90 will be error. Tangent negative 270 will be error. So these are called the asymptotes. So how do you think the curve will look like? So tangent 0 will give you 0. Okay, so that's 1 point there. And then tangent 45 will be 1. Okay, so here, sometimes in your curve sketching, they will require you to indicate this point. So if you're sketching for y equals to tangent x, tangent 45 will be 1. So this is how the curve will look like. It's basically a quite interesting looking curve. Oh, wait, I need to change. Okay, put it more accurately. Right, so it will not touch the line at x equals to 90. Right, it will not touch that. So basically, this is also the asymptotes. Okay, it will not touch. It will just go all the way up. I'm not quite understand why it's like that. It's so mysterious. And then tangent 180 will give you 0, so it will go down. Okay, it will not touch the line at x equals to 90. It's very interesting. So that is one cycle. Okay, that's one cycle. Alright, so you can just repeat another cycle. Okay. Then for the negative part, it will be the green. The different colors gives you the cycle. So the blue and the blue gives you one cycle. The red and the red give you one cycle. Green and green give you one cycle. Orange and orange give you another cycle. So actually for tangent curve is a much easier curve to sketch than the sine cosine. Okay, so in this case here, you're sketching negative 4 tangent 3x, so it's this inverted one. Alright, so that's find period first. So period is just 180 degrees divided by the coefficients of x. The coefficients of x is 3. So it's just 180 divided by 3. It's the same way as what we do for sine and cosine. Right, so 60 degrees. That means 60 degrees is the range where I can get one cycle. Right, so the asymptotes will happen at 30 degrees. Okay, just like remember when we sketch y equals to tangent x, right? The period is 180. The asymptotes happen at 90 degrees. So here the asymptotes happen at x equals to 30. Because 30 times 3 gives you 90, right? Tangent 90 will give you error. Alright, so it happened at 30 degrees. Also happen at 90 degrees because 90 times 3 is 270. Tangent 270 will also give you error. Okay, so let's sketch the first cycle first. Okay, now it's the other way around because it's negative 4. Right, so tangent 45, it's 1, right? So 1 times negative 4 gives you negative 4. So therefore, the curve will go this way, this direction, and the other direction. So that's one cycle. So you need to sketch all the way until 120, right? So you need another cycle. So to summarize, for tangent curve is very easy to sketch. You just need to find the period and find the asymptotes. Asymptotes is half of your period. That means if your period, let's say, is 90 degrees, then your asymptotes will happen at x equals to 45 degrees. Or if your period is 130, then the asymptotes will happen at 65. Right, so in the next few slides, we're going to look at some possible exam questions on the sine and cosine curve sketching. Okay, let's look at this question. So you're given the diagram, and this one clearly is an inverted cosine curve. Okay, the upright cosine curve will be, okay, like a buttercup or whatever, shapes that you want to call it, like a belly or like, a head turned the other way around. Right, so this is an inverted cosine curve, and we can recognize that one cycle, that is one cycle. And so the range is between 0 to 12 pi, so therefore the period is 12 pi. And if we were to recall how we can find period, to find period is, in this case, we're talking about the unit in radian, so it would be 2 pi divided by b. Right, so what you need to do first of all is to rewrite your y equals to a cos x over b plus c. You need to pull out the coefficients of x. Okay, this is what I mean. Pull out the coefficients of x. The coefficients of x here is not b, it's 1 over b. Right, because x over b, all right, is actually equals to x over 1 times 1 over b, or 1 over b times x. Gives you 1 bx. Okay, so the coefficients of x is 1 over b. Okay, this is something you must take note. So therefore, we take 2 pi divided by 1 over b, will gives you 12 pi. Okay, and 2 divided by 1 over b, 2 pi divided by 1 over b, you can just times b at the denominator times b at the numerator to just get 2 pi b over 1. Okay, this one will end up 2 pi b over 1, which is just 2 pi b. So 2 pi b equals to 12 pi. So b is 12 pi divided by 2 pi gives you 6. That's how you find the values of b. Alright, then how do you go on to find other values, the other variables? Let's take a look. So the amplitude is taking the maximum y minus minimum y divided by 2. So if you were to look at the curve, the maximum y value is 3 here. The minimum is 1. So 3 minus 1 divided by 2, that gives you 1. So the amplitude is equal to 1. Right. But the amplitude doesn't represent the values of the A. Right, because this is an inverted sine curve, A is equal to negative 1. Amplitude is always positive because amplitude refers to the height of the curve. Okay, it's always positive. Okay, but because this is an inverted curve, my A must be negative 1. Alright, then how do you go on to find the values of C? Do you remember? Yes, we take maximum y plus minimum y divided by 2. And in this case here is 2. So this is how you solve this question. Alright, so for question 2, you see that it carries a lot more marks. If you were to add up the total number of marks, there will be 4, 5, 6, 7, 8, 9, 10 marks altogether for these questions. Right, so for the first 4 parts, relatively easy questions. Relatively easy. Right, part I, you asked to find the least value of fx. Right, we're going to substitute sine 2x to be negative 1. And then substitute sine 2x to be 1 to find the greatest value. So the least and the greatest value refer to the minimum and the maximum value, which is what we have done early on. We can refer to the earlier examples. Okay, and then for part 2, the least value of gx will be, we're going to substitute cos bracket x over 2 to be negative 1. And for the greatest value is to substitute cos bracket x over 2 to be 1. Alright, so part 1 and 2 are relatively easy. We've done it before already. And then for part 3, it's not difficult also. To find the period of fx, basically, is just 360 degrees divided by b. In this case here, the values of b is 2. If you were to compare it with your general form, right, this is what I mean. Right, so in this case here, your b is 2. So the period will be 360 divided by 2 gives you 180. Alright, so for this is slightly harder, but it's not difficult also. I've done it before, so you just need to rewrite it as 3 cosine half x. Okay, remember? Right. X over 2 is x over 2. So the coefficients of x is half, not 2. Okay, so you take 360 degrees divided by half, that gives you period 720. All right. Okay, so with that, in the next slide, we're going to sketch both graphs. All right, so let's sketch the sine curve first. It's easier. Y equals to fx. So we're sketching fx equals to 2 sine 2x. So we found out earlier on that the maximum value is 2, minimum value is negative 2. Okay, so when you substitute, so for y equals to 2 sine 2x, okay, if you substitute this to be 0, that means you substitute x to be 0, sine 0 will give you 0, right? 0 times 2 is 0. So your first point will happen at 0, 0. The first point will happen here. And then, of course, the next point will be when you substitute your sine 2x to be 1. That's the maximum value, right? Maximum value. So 1 times 2 will give you 2. So this is your maximum value of y. And then you substitute your and that happens, okay, when you let sine 2x equals to 1. That happens when your 2x is 90 degrees, right? So your x will be at 45. Okay, we have also done that earlier on, but if you've forgotten, just refer to the earlier slide. Okay, so sine 180 will be 0, so that explains the point. All right, and the minimum value of your fx is negative 2, right? So that happens when you let sine 2x to be negative 1, right? That is when your 2x is equals to, what's the angle, do you remember? Yes, 270 degrees, so x is 135, which explains this value here, 135. Okay, right, and because you're supposed to sketch all the way from 0 to 360, you will need to continue with another cycle. Okay, so that is your y equals to 2 sine 2x, right? Then how about gx? So for gx, we know that the period is 720. So 720 is one cycle. Okay, but because you're sketching it only up to 360, so it's half a cycle. Okay, your full cycle will look like this, right? This is how your full cycle will look like. This is at 0 degrees. This is at 180 degrees. This is at 360 degrees. This is a full cycle for y equals to cos x. Right, so if you're talking about if your period is 720, wait, hang on. Your period is 720, then this is how it looks like, right? You start with 0 degree, 360 degree, and then 720, right? Okay, so if you are just sketching from 0 to 360, then it's just half a cycle only. You just need half of it only. Okay, right, so the first value is your maximum value, which is when you let your you're sketching this graph, right? Is when you let this to be 1, right? So the maximum value will be 2, and that happens when the x is 0 degree, right? So your first point will be here, 0, 2. Okay, x is 0 degrees, and the maximum value of y will be 2. So that will be your first point, and then the second point will happen at, let me erase all this. Okay, your second point will happen at when the minimum value we calculated to be negative 4, and that is when I let it to be negative 1. When I let cos x over 2 to be negative 1, right, to get negative 4. And so that happened when my x over 2 is at 180 degrees, right? Because cosine 180 is -1. But now I'm having x over 2. So I need my x to be 360 degrees. So the second point is at 360 -4. Oh, I've provided another point to make the curve sketching, to make the cosine curve easier to sketch. So the second point I provided is when I let your x to be 180, right? So 180 divided by 2, that would be 3 cosine 90 minus 1, so that gives you 2. Sorry, cosine 90 will be 0, that gives you -1. Let's explain this point here. This value is -1. Okay, so joining these 3 points up, this is how your cosine curve will look like. Okay. All right. Okay, let me erase all this. Okay, so then for part 4, we asked to find the number of solutions for the equations. Okay, 2 sine 2x plus 1 equals to 3 cos bracket x over 2. So basically, if I'm going to take -1, subtract 1 on both sides, subtract 1 on both sides, you see what happened? Huh? Yes, if you subtract 1 on both sides, you'll see that you actually get 2 sine 2x on your left hand side and 3 cos bracket x over 2 minus 1 on the right hand side, which is actually exactly the functions we've just sketched. Right, so therefore the number of solutions will be the intersection points of these two curves. And from there, we can see that there are 3 points. Okay, right. Right, so this is a very big congratulations to all of us. We have made it. We have completed the trigo curve sketching on sine, cosine, and tangent. Right, and all this knowledge we have just learned, I promise you will be enough. If you learn it well, and do a little bit more practices from the textbook and the past papers, I'm confident that you will be able to solve any questions in the coming exam. So good luck to you.